All right, guys, for this last section, we finally get to formalize a little bit of the calculus we've been working on. And that's by naming something that we have been finding. So this last section is called the derivatives and the tangent line. Now, a derivative, this new word that we're going to be using, is actually something that we have just been finding using our difference quotient. So the derivative is this expression that we found in the last section using our difference quotient. It's that little formula that we have found to represent the slope at any point. Okay, so the derivative is the expression from the difference quotient that shows the slope of the function. So it's that step before plugging in an actual x value. So again, for this last function, it would have been just 1 over square root of x. That's the derivative of the function. A couple ways we can name it. You'll see it most commonly written like this, in which we call f prime of x. That is the derivative, or that expression for slope. You'll also see it like dy over dx, because remember, difference of y, difference of x, that's slope, or even delta y over delta x. There's probably some other ones that'll pop up. I will be using this f prime of x expression. Okay, so let's go ahead and jump in. Function is f of x equals square root of x. I would like to find f prime of x, which again, we just named as our derivative of x. And we will find that using our difference quotient. So I'm going to start out with my limit, h to 0. I need f of x plus h. So if I come off the side, f of x plus h is just that same function. I'm going to plug in an x plus h instead of x. Okay, so it's the square root of x plus h, and then subtract off the original function, square root x divided by h. Doesn't look like a whole lot of simplifying or any subtracting I can do here, but I do see some radicals on the top. So let's go ahead and use our rationalizing technique to unrationalize this thing. Okay, multiply by the conjugate, square root of x plus h plus square root x. Oops, I'm going to change that. Over square root of x plus h plus square root of x. And then when we multiply it, hopefully some nice things will happen. So I still have my limit as h approaches 0. First times first is just going to cancel that radical. So that just leaves me x plus h. Outer guys, I'll have a positive and I'll have a negative. So they're gone. And then my negative square root x and my positive square root x just make an x. So minus x. Denominator again, do not simplify as you're multiplying out. Just write it, because then nice things should happen. Okay, so in that numerator, I can see that my positive x and my negative x are going to zero out. I can also see a step ahead, and then I'm going to have an h over an h. So I'm going to go ahead and cancel those two, leaving just that 1 in the top from my 1h. Okay, so it looks like I have the limit as h approaches 0 of 1 over square root of x plus h plus square root x. Okay, not a pretty expression, but remember, once we've done all the we can, we should be able to now do our direct substitution and plug in our 0 for the h. So I'm plugging in the 0. Okay, if this becomes a 0, I have a square root of x plus another square root of x in the denominator, which equals 1 over 2 square root of x. So this is what I would call my derivative, f of x. And again, all this means is that this is what I can use to find the slope at any point on my function. Okay, so now moving on, what's the slope at x equals 1? All right, so I want to find the slope at x equals 1, which means I'm going to use my derivative, and I'm going to plug in 1. Okay, derivative tells me slope. That's where I want to find the slope at. So it would be 1 over 2 times square root 1. Square root 1 is just 1. So it looks like at x equals 1, my derivative is a half, or my slope is a half. And I got that from my derivative. Okay? Okay, so let's go a step further. Can we now write the equation of the tangent line at x equals 1? Now, if you remember anything about circles in Math 2, a tangent line is a line that just brushes up against something. Okay, so when we are finding the equation of a tangent line, what we're going to do is we're going to write the equation of a line that just touches my function at that point. And what I need to know for my line is a point and a slope, right? The cool thing is the derivative at that point is the slope of the tangent line. So that's why we do this. Okay, we're going to use the information we just found to help us write the equation because that has told us now the slope. So if m equals 1/2, because I just used my derivative to find that, I've got an x value from my tangent line. I don't know the y value, but I can use my original function to find that y value for the x equals 1. Okay, so we're using both the derivative and the original function here. If I plug 1 into the derivative, I get the slope. If I plug 1 into the original function, which was just square root x, then I get the y value. Okay? So basically what I have now is an ordered pair. X was given to me, y I just found, and I have a slope because I plugged that x into my derivative. Okay, so let's use this point and this slope, and I'm just going to use point slope form. So y minus y1, so y minus my y value, which is just 1, equals my slope, and then x minus x. And just like we did when we studied hyperbolas and wrote asymptotes, I'm going to leave it in this form. That's a perfectly acceptable form of a line. Okay, so this is a line that just brushes up against the function f of x with the appropriate slope through the appropriate point. Okay, and that's how we'll use that derivative. So just a shortcut. To find the slope, what we're going to do is we're going to plug the x value into the derivative. Okay, to find the y value for that tangent line, we plug the x value into the original function. Okay, so I use the original function to find a y value. I use the derivative to find the slope. And that is your introduction to calculus.